Yes, thank you very much, Birgit, for this nice introduction, and a very warm welcome to everyone who is attending our first webinar about gut health and probiotics. To make this webinar a little bit more special and interactive, we included different tools. When you see the first symbol and the last symbol here shown on this slide, you're actually supposed to take action by answering a tricky question or by deciding the topic that should be discussed at the following slides. The mind blowers you can see here in the middle, they are most of the time following the do you know questions and are sort of fascinating facts or fun facts. With this, we are actually set up and can take a quick look at the agenda for today. You can see that our webinar is simple structured but straightforward. Before we talk about probiotics, their history and modes of action, I think it's very important to cover the background of the gut itself, the gut function and intestinal health, including the gut microbiota. This information will be mostly based on human research, since the human gastrointestinal tract is the best investigated one. However, this kind of knowledge, at least most of it, can be easily transferred or is applicable for animals and their intestinal health. And after a more general probiotic section, Alina will give you at the end a nice overview about different probiotic feeding strategies, including the probiotic categories, advantages, and application areas. With this, we can start. And you will also get the first question after I show you a small evolutionary flashback. So on this timeline, you can see that the formation of Earth was round about 4.5 billion years ago. The first accumulation of oxygen was 2.3 billion years ago, by the way, here by cyanobacteria. And to have another reference point more out of the present, the domestication of poultry was round about 8,000 years ago. So with this in mind, what do you think? When evolved the first functional gut microbiota and the first functional gut? Was it 1.1 billion years ago, 2.4 billion years ago, 0.7 billion years ago, or 0.03 billion years ago? So we have a clear winner, answer number B, was 2.4 billion years ago. So this is a little bit too long ago because, as I mentioned earlier, the oxygen accumulation in the atmosphere occurred only 2.3 billion years ago. And we all know that animals are dependent on oxygen for their metabolism. So better answer would be round about 1.1 billion years ago. You can see on this fossil here that there are worm burrows in the stone. And we all know that, simply spoken, worms are not more than a primitive gut crawling around, ingesting their environment and bacteria to gain energy. When we now go back to our timeline, we can see that this amazing symbiosis between bacteria and primitive animal guts existed long before other more complex animals such as fish, mammals, or birds. This also shows us that this combination had billions of years to evolve to such a complex, or to such complex intestines and sometimes very specialized microbiota as we know them, for example, from ruminants. And that brings us to our next topic, the gut microbiota. Especially, as I mentioned before, the human gut is very well investigated, and also its microbiota, and comes at the same time with fascinating facts. Some of them I would like to show you today. So the human gut microbiota consists of around about 100 trillion microbes, which is this fancy number down here. This adds a body weight of approximately 2 kilograms. I'm sure that some of us will think about it the next time on the body scale. What is also fascinating is that all microbiota are unique. Even identical twins are not having an identical microbiota. You can consider them as personal microbial fingerprint. Also, fascinating. The microbial composition is a dynamic equilibrium and varies depending on where you live, how old you are, or your lifestyle. Are you smoking or not smoking? What is also known is that the diet is the most powerful influencer. Besides goodies such as probiotics or fiber that support our good bacteria, there are others like emulsifiers and preservatives that can damage the gut and its function. Fascinating too is that stress can influence our composition, and these alterations further contribute to stress and anxieties. There are good and bad bacteria inside of us. Important here is to keep the balance. And friendly bacteria, so probiotics, are right now the most famous and popular way to support the microbial balance inside of us. What I also want to point out here is that we still have a lot to learn. Although the knowledge about the microbiota is increasing rapidly in the last years, there are still hundreds of open questions, including the question, what are the precise mechanisms and factors that contribute to a healthy microbiota? To keep it a little bit more simple, we can say that there are two important pillars for intestinal stability. The functional microbiota we just talked about, but also a functional epithelium, including an efficient gastrointestinal barrier and the absence of inflammation. Only when these both are working perfectly together, we can maintain and talk about intestinal stability and integrity. And that brings us actually to our next topic. So the gut epithelium or the gut morphology, also here associated disorders. And like before, I would like to start the new topic with a question for you. So what do you think if we would unfold all invaginations and enlargements of the gut? How large is the human intestinal surface when we consider a 2D area? Is it around about 1 square meter, 10 square meters, 20 square meters, or even 30 square meters large? So let's take a look. That is a great answer. You're completely right. And I'm sure that also all of you know that the human gut is several meters long. To be a little bit more precisely here, round about 7.5 meters. And as you already answered, at least most of you, if we would unfold all enlargements of the human gut, we would end up with approximately 32 square meter area, which is a half badminton court. This huge area is needed for an efficient nutrient absorption, but also other very important mechanisms and processes, for example, protection and excretion. The enlargements of the gut are invaginations and called villi and microvilli. The villi you can see here on the left side, and the microvilli are located on each single cell. The organization of the gut epithelium itself is quite simple. We can talk here about a one-cell layer that is rich on blood vessels to facilitate efficient nutrient absorption. When we now zoom in, we can see that there are different epithelial cells and important proteins. The enterocytes, for example, they are the ones for the efficient absorption of nutrients and water. The panothels, they are key mediators of host microbe interactions. They are known to excrete antimicrobial peptides and proteins to support the microbial balance. Goblet cells here are necessary for mucus production, and they form the protective barrier, which is necessary to prevent the direct contact of the gut content to the epithelial cells. And as mentioned before, important proteins, here in this case tight junctions, you can see them between the single cells. They prevent the leakage of the gut content into the bloodstream by sealing the paracellular pathway, so the space between two cells. So with all this background information and knowledge, with sensitive microbial balance, potential pathogens, different protective mechanisms, you can for sure imagine that something can go wrong. And that's exactly the case when we talk about a gut dysbiosis or a leaky gut. What is a gut dysbiosis? So this is actually the opposite of a gut eubiosis and describes an imbalanced microbiota with an overgrowth of harmful bacteria. The precise mechanisms of the gut dysbiosis or that contribute to a gut dysbiosis are very complex and till today not fully understood. What is known, especially again from human research, is that parameters such as genetics, mental or oxidative stress, diet, including food allergies, pathogens itself, and their toxins can contribute to gut dysbiosis. This leads to the loss of the gut barrier and integrity, which starts a devastating cascade that begins with an immune reaction and ends with the depletion of the important tight junctions, which increases the gut permeability. That, of course, leads to an even worse and more serious immune reaction, and at the same time to chronic inflammations and the loss of the gut function. In fact, a damaged gut is not longer able for an efficient nutrient absorption, secretion, or protection. These disorders, a gut dysbiosis and a leaky gut, are also playing major roles in animal production, independent of the animal category. For example, in poultry production, both are well-known predisposing factors for necrotic enteritis. And especially after the ban of antibiotic growth promoters in the EU, but also other regions, necrotic enteritis became a serious issue for farm profitability because it worsens the feed conversion and it leads to high mortality rates up to 50%. So what we really want to maintain is a balanced microbiota to maintain gut health, to maintain overall health. But when we take a closer look at intestinal health and try to define it, we quickly realize that this is more a multifaceted, complex concept instead of a simple statement. Stephen Bishop summarized or published 2011 a very nice summary about the aspects that should be considered when we talk about intestinal health, including efficient nutrient absorption, effective digestion and immune status, absence of gut illness, including inflammations, and here we go again, a balanced microbiota. Only when all of them fitting perfectly together, we can talk about intestinal health and the chance for a status of overall well-being. That influences our productivity and quality of life, or in case of animal production, for example, the growth rate and the performance. But the gut itself is not only a huge bioreactor turning food and feed into nutrients for final nutrition. You can see here the gut in all its dimensions. So the activity and conditions of the gut are closely connected to other organs, processes, and tissues. So researchers discovered one by one different linkages that are connected to the gut, starting with the gut-brain axis, the association to the immune system, the gut-lung axis, the gut-liver axis, and the association to muscles and bones. So based that the gut-brain axis and the gut-lung axis are right now the best investigated ones, you can decide if you would like to hear more about the gut-brain axis or the gut-lung axis. Okay, bugs making drugs. Perfect. So, like the gut-lung axis, the gut-brain axis is multifractional and bidirectional and includes different important connections, for example, enteric, spinal, vagal, but also hormonal pathways. In this way, the microbiota is able to reach out and influence mental health, including behaviors, but also moods like depression, aggression, or anxieties. But how do they do this? I know it sounds weird, but the bugs are making drugs for us. Especially bacillus and lactobacillus are well known to produce neuroactive substances. For example, GABA, serotonin, dopamine, and histamine. GABA is very interesting because it acts as an inhibitory neurotransmitter, and in simple words, it can slow down brain activity and leads to relaxation. This research area has even created a new term, psychobiotics, which are probiotics that should support, or that are made to support, mental health in human. Also very well fitting to this topic is that the gut microbiota and also certain probiotics are known to influence appetite, feed food intake, or eating behavior. However, if psychobiotics or specific probiotic appetite booster are playing a bigger role in the future regarding animal production, is very dependent on further extensive research. Let's skip this. So before we go to our next topic, probiotics, I would like to sum up the main points of the previous section. So the gut function, the microbiota, and gut health. So yes, gut health really matters because a healthy and balanced microbiota is crucial for animal production and performance. Why? Because it facilitates efficient feed digestion. It keeps pathogen under control, including the training of the immune system and the development of the immune system. And also, we saw it earlier, the gut microbiota is able to affect other body parts, for example, the brain and the lung, which has maybe in future the potential to be mentioned when we talk about animal welfare or respiratory health of animals. So to keep a stable animal performance without using environmentally polluting high dosages of zinc oxide, and antibiotic growth promoters comes with a stable profitability or even a higher profitability, but at the same time, on top of it, with a good feeling, peace of mind. One way to avoid this high dosages of zinc oxide and antibiotic growth promoters are environmentally friendly probiotics, and we mentioned them earlier. So farmers around the world are already successfully using probiotics to support their intestinal health of the animals, to prevent the dysbiosis, so that the animals stay healthy, high performing, and at the same time prepared to fight against incoming challenges, for example, pathogens. Also interesting is that we see a turning point in human medicine. So antibiotics get replaced more and more by probiotics. But what are probiotics? So the WHO and FAO defined them 2001 as live organisms which, when administered in adequate amounts, so dosage is really important, confer a health benefit on the host. And in animal production, the aim is to optimize the animal performance while maintaining intestinal health. Before we take a quick look at the history of probiotics, I have here for you the last do you know question for today. So what do you think? Since when is humankind consuming probiotics? Is it 2,000 years ago, 5,000 years ago, 7,000 years ago, or 1,000 years ago? So let's see, 36% are choosing 7,000 years ago. So that is again a very good answer, and you're right. As so many things in history, also the first probiotic food was a kind of accident. When humans started to store milk, and especially under higher temperature, that led to a natural souring process called fermentation, and the first probiotic containing food, yogurt. Only several thousand years later, we started to make sauerkraut, which is another very famous and healthy probiotic food. For me, the mind blower here is actually not that we're consuming probiotics since 7,000 years. I found it more interesting that it took us so long until we realized that bacteria in the food have these nice health beneficial advantages. We know about probiotics only since 114 years, when Elie Mechnikov, a Russian scientist and Nobel Prize winner, noticed that some individuals in Bulgaria lived longer than others, over 100 years. After he figured out that they're drinking fermented yogurt on a daily basis, he discovered that probiotics, so bacteria in the yogurt, improved their health and might have provided or supported their longevity. But why are probiotics so beneficial for animal health or human health? So the answer is complicated and easy at the same time. Without getting lost into details, we can simply say that probiotics are able to support and comprehensively support all the complex mechanisms and processes we know from the microbiota, but also from the gut itself. But how do they do this? And that's exactly where it gets more complicated. Different probiotics are coming with different modes of action. Almost all of them are able for competitive exclusion by competing for nutrients and space. Others are able for specific bioconversions. For example, they're using nutrients and produce neuroactive compounds. We mentioned that earlier. Probiotics are also able to produce nutrients and vitamins for direct antagonism, which is the direct suppression of harmful bacteria. Others can support the barrier function, modulate the immune system, or they're reducing inflammations. We could fill another whole webinar with each of these modes of action. But as before, I made a pre-selection, and you can decide if you would like to hear more about the production and availability of nutrients driven by probiotics or immune modulation. Okay, most of you choose immune modulation. So let's go ahead and skip this very fast. Okay. So this topic is quite complex and all the precise mechanisms are till today not fully understood. What is known is that probiotics come with specific molecules, for example, special parts of their cell wall, or they excrete molecules such as double-stranded RNA, but also DNA. So these extracellular molecules can be recognized by the immune system, and in this case represented by dendritic cells. They get stimulated and they start producing cytokines, for example, very specific interleukins. That again, or these interleukins and molecules are recognized by B cells, which then upregulate the production of antibodies. For example, immunoglobulin A. So IgA is a very important antibody on mucosal surfaces and belongs to the first line of defense. Why? Because it is able to prevent the adhesion of harmful bacteria, but also viruses, and at the same time, it can neutralize bacterial toxins. In this way, IgA is very important when we talk about a healthy gut environment. So I hope you got an idea how comprehensively bacteria or probiotics, they are bacteria, can support the intestinal health by supporting the very, very complex mechanisms and processes known from the microbiota itself, but also the gut. Before I hand over to Alina, I would like to sum up the main points of my talk. Perhaps the most important take-home message is that the intestinal health is more a complex, multifaceted concept instead of a simple statement. And intestinal health is strongly dependent on a balanced microbiota. However, this balance is very sensitive, and especially in animal production, an imbalanced microbiota, so a gut dysbiosis, mostly results in an impaired feed conversion that leads to a poor performance drop. However, farmers around the world have the option to use environmentally friendly live organisms to support intestinal health and preventing such a dysbiosis. Especially based on their different and various modes of action and the well-documented improvement of animal performance under a variety of different farm conditions worldwide, probiotics and not high dosages of zinc oxide or antibiotic growth promoters became key players in animal production. And with this, I'm actually at the end of my part. Thank you very much for your attention. Alina, the stage is yours.
Thank you very much, Lydia, and a warm welcome to everyone also from my side. I hope you are still hanging in there because now we are switching from a broad and general overview to specific probiotics used in animal nutrition. As Lydia already mentioned, it is not only the absence of intestinal illness, but also other certain parameters defined as in human gut health and animal husbandry. Among nutrient absorptions, an efficient digestion and effective immune status is a crucial aspect of animal health and performance. But how can we maintain or support intestinal health of our livestock animals? There are several different adjusting screws in animal production to support animal gut health. Besides the herd management itself, medical treatments such as coccidiostats, sanitary management, for example, cleaning and disinfection, but also water and feed management, including water quality and sanitary, feed formulations and feed additives are important adjusting screws in animal performance and overall health. If we now take a closer look at feed additives, we all know that especially antibiotic growth promoters and high doses of zinc oxide were used to inexpensively control pathogens by promoting and stabilizing the intestinal health and performance of animals. Driven by the emergence of multi-antibiotic resistant bacteria and environmental pollutions, political systems worldwide, such as the EU Commission, agreed to serious restrictions regarding the usage of antibiotics. But also the application of high doses of zinc oxide will be banned started in the EU next year. Thus, the need for reliable alternatives are growing rapidly in the last couple of years. But we also have good news. There are a broad range of options how we can positively influence and stabilize gut health in your livestock without AGP or high doses of zinc oxide. The three main categories currently used to support intestinal health and function are organic acids, prebiotics, and surprise, probiotics. We offer these additives tailor-made to have a perfect combination, including synergistic effects that fit the needs of your animals. Today, especially probiotics are the best investigated and most popular feed additives when we talk about supporting digestibility, gut development, the microbiota, and overall gut health, which in turn reduces the risk for gut dysbiosis and the need for antibiotic intervention. Since they have such an amazing effect on overall health, including animal performance, industry is continuously researching and identifying new strains to improve probiotic efficiency. Although there's therefore an endless diversity of probiotics on the global market, they can be assigned to three main categories. The first probiotic category I would like to highlight are the bacillus-based probiotics. These probiotics include spore-forming bacteria such as Bacillus subtilis and Bacillus licheniformis. Their application focus lays on monogastric animals like pigs, poultry, and calves. Each category comes with specific advantages. In case of common spore-forming bacteria, these advantages are heat stability and pressure insensitivity, which makes them great candidates for common pelleting processes, but also the suppression of gram-positive pathogens, immune modulation, and exoenzyme production are key mode of actions that support the microbiota balance and feed digestibility. The second category covers lactic acid bacteria. They are like bacillus-based probiotics widely used in animal and in human nutrition. In animal nutrition, this category includes bacteria species like Enterococcus, Faecium, Lactobacillus, and Pediococcus axilactici, which are due to the rapid colonization of the intestine, especially beneficial for young animals and therefore used the milk replacer for piglet and calves, or in the hatchery for chicks. The intestinal producers lactic acid have several advantages. It can be used as energy source by the host, but also as inhibitory effect on pathogen based on a reduced pH. At the same time, lactic acid can stimulate other beneficial gut bacteria. And finally, live yeast. This category is mainly represented by Saccharomyces cerevisiae. The probiotic properties of live yeast are primarily beneficial for ruminants and horse, but also for sows. Besides an enhanced fiber digestibility, live yeast are able to indirectly suppress lactic acid producing bacteria and thus lower the risk of the dreaded rumen acidosis. Although each probiotic category comes with its own upsides and downsides, all three are known to improve animal performance, including daily weight gain and feed utilization. But with so many different options, it is not easy to find a probiotic that perfectly fits to the need of your animals. Therefore, I would like to mention few main properties a reliable probiotic should have. To improve animal performance, a probiotic needs to have a relevant mode of action, for example, pathogen inhibition. On top of this, it would be of advantage when a probiotic comes with more than one mode of action, for example, pathogen inhibition and exoenzyme production. Furthermore, a probiotic should be unique with very specific strain characteristics. For example, simply spoken, Bacillus subtilis A is not equal to Bacillus subtilis B. Strain really matters. Trustworthy probiotics are safe to work with regarding human health, and their efficacy should be scientifically proven and documented under different conditions. Unfortunately, we cannot talk about all three categories in detail, but I would like to briefly highlight the benefits of bacillus-based probiotics. In general, bacillus probiotics are available in vegetative or spore forms. Vegetative cells like lactic acid bacteria or live yeast are sensitive to humidity and heat, while spore-forming probiotics like bacillus are naturally strong when it comes to withstanding heat, pressure, or stomach acids. As mentioned before, especially the heat and pressure resistance make bacillus probiotics a great candidate for common pelleting processes. Furthermore, it is important to note that all the host relevant benefits of a certain probiotics are only showing an effect on animal performance when a reliable high dosage of a probiotic is used. Bacillus-based probiotics are also well known to efficiently suppress pathogens, boost the immune system, and produce exoenzymes. That in turn supports the gut microbiota balance, enhance the immune defense of the animal, and at the same time increase feed digestibility. But again, the efficiency of a probiotic is based on an effective strain and its dosage. So let's put all pieces together to get a final picture for today. Probiotics are key players in gut health and animal production, based, first of all, on a high diversity of mode of actions like pathogen inhibition, immune modulation, and exoenzyme production. Therefore, there are attractive and environmental friendly solutions and thus a reliable alternative to AGP and high doses of zinc oxide to stabilize intestinal health and improve of overall health and performance in livestock. All in all, to safely support an efficient and sustainable animal production that in turn increases your farm profitability with peace of mind. With this, I would like to thank you very much for your attention, and I'm already looking forward to some questions from our Q&A chat.
Yeah, perfect. Thank you very much, Lydia and Alina, for giving us such a compact overview on intestinal health and the beneficial effects of probiotics, including feeding strategies to increase and stabilize animal performance and farm profitability. So that was really interesting, and I have to say, I hope the audience learned also a lot like I did today, so there was a lot of new insights here in your presentations. We received some questions, and I would like now to continue with a short question and answer session. I'm just checking the chat, and maybe the first question here is, I think, more addressed to Lydia. It's about the gut lung axis. So you shortly mentioned the gut-brain axis and these connections, and now we have a question about the gut-lung axis. So can probiotics also affect respiratory health?
Yeah, that is actually a very good question, and I'm happy to answer this. So like the gut-brain axis, the gut-lung axis is very complex. And the cool stuff about the gut-lung axis is actually that the gut or the lung comes with its own microbiota. And this both microbiota are able to crosstalk with each other using the lymphatic system and the blood system. And there is an increasing evidence that probiotics can influence respiratory health by influencing the immune response in the respiratory tract. Also very fitting or well-fitting to our current situation is that scientists around the world seeing probiotic as potential strategy to improve or to treat and prevent viral respiratory infections, for example, also COVID-19. So this shows again that the gut microbiota and also certain probiotics are really able to support overall health by preventing serious respiratory diseases or their severity.
Okay, yeah, thank you very much, Lydia. And now I would like to select here one question which is more addressed to Alina's part of the presentation. And here it's a question, which dosage is commonly used on the market? I think it's related to animal production. So which dosages of probiotics are commonly used? You mentioned a high dosage is important, but what is your answer here?
That is also a very good question that even takes us really busy. The range of the recommended dosage is varies extremely. For example, even in the EU, the recommended probiotic dosage vary from 1 × 10⁻⁷ to 1.6 × 10⁻⁹. This, of course, is also associated to the financial questions. How many CFU or probiotic bacteria cells do I get for my money? This considered makes it even more important to take a closer look at the product specifications.
Okay. So now we see there's a lot of questions coming up now at the end of our session, but due to time reasons, I would now like to select one more question, a last question from the chat. And let's check. So there's a question also addressed here to Alina. So we see there's a lot of questions now, practical questions related to animal production. And the question is about the compatibility with probiotics and feed additives. So what do you recommend? A combination, for example, of organic acids and probiotics, or are there inhibiting factors?
As also very interesting questions, and I'm happy about answering these questions in a bigger group since we get this kind of questions frequently. There are no inhibitory effects of organic acids and probiotics, but there are different mode of actions. In case of organic acids, a probiotic would have synergistic effects, especially the small intestine is very well known for its efficient absorption of smaller compounds, such as organic acids. So it will be mainly absorbed right after the entry in the intestinal tract. And probiotics, in contrast, are whole and active microorganisms that are not absorbed by the gut epithelium. Therefore, they can produce organic acids during the entire gut passage. Organic acids like lactate, for example, and especially when other feed-driven organic acids are already absorbed, they used by the host, the production of the additional organic acids of the probiotic is known to support the microbial balance by, for example, lowering the pH and stimulating other health beneficial bacteria, or they can serve as energy source for the host. So it's we can use it both together, but there are more or synergistic effects when we use a probiotic and not an organic acid.
Okay, so yeah, and you highlighted it also in your presentation that especially with the Bacillus probiotic, there's a very good compatibility to other feed additives such as organic acids. So that's, yeah, thank you very much for your answer. Due to time reasons, I would like to finish now the session here. First of all, I would like to thank you again, Lydia and Alina, for the very nice presentation and the very good comprehensive overview on gut health and probiotics in both human but also animal human nutrition and animal production. So for those whose questions are not answered yet, don't be afraid. We will be able to answer your questions soon via email, so you will get an answer to your questions later via email. At this point, I would like to inform you also about our upcoming webinar. So we will have a further webinar on the 6th of July with the topic Understanding Endotoxins, how can feed additives counteract this ever-present risk? So it's also mainly related a little bit to gut health, but here more the focus on endotoxins. I'm pretty sure that this will also be a very, very interesting topic and presentation given by Dr. Cornelia Becker. So for today, I would like to thank you all for your time, participation, and interest of our today's webinar, and would like to finish now the webinar with my last words. Goodbye and stay healthy.